Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to be discussing everything you need to know about compound interest to be successful on the Armed Services Vocational Aptitude Battery, that is the ASVAB. First, let me stress this, since I know most of you are probably looking at this formula here. In my experience, you do not have to memorize this formula. In fact, if you see a question regarding compound interest on the ASVAB, chances are this formula is going to be provided to you. That said, you do have to understand the ins and outs of this formula in order to answer the questions correctly. And so in light of that, I'm going to spend the first part of this video breaking down and discussing each and every part of this formula. After that, I'm going to work out 2 practice problems with you. And then finally, there are going to be 3 practice problems in this video. Once you reach that part of this video, I strongly encourage you to pause the video, attempt to work out the question on your own, and then resume playing the video to check your solution. So all that being said, let's go ahead and get started with today's video. So the formula to find compound interest is given by A equals P times 1 plus R over N in parentheses raised to the N times T power, where A stands for the total amount in the account. So after you invest a certain amount of money over a certain period of time and with a certain interest rate, you'll have A amount in your account in total. P, of course, is your principal amount, and that's the amount that you invest. Okay, so as we look through these word problems, you'll see that I'll identify P as the amount that you invest. R is your annual nominal interest rate, and you're always going to express that in this formula in decimal form. So for example, if we're told we have an interest rate of 5%, in decimal form, that's going to be 0.05. N refers to the number of times the interest is compounded per year. And as far as N goes, there is some vocabulary with which you need to be familiar. In the word problems, you're going to see these words: annually, semi-annually, quarterly, monthly, weekly, and daily. Annually refers to 1 time per year, so N would be 1 in that case. Semi-annually means twice per year, so N would be 2. Quarterly means 4 times per year, so that N would be 4 in that case. Okay, so just bear in mind that that's how you derive N from the word problems. And then finally, T is always the number of years you invest the money. So honestly, apart from telling you what each of these letters stand for, I want to stress this as well. More often than not, you're going to be asked to solve for A. That's going to be the most common type of question you'll see on the ASVAB. That said, if you're doing especially well, you might see a question in which you have to solve for P. And as you'll see in just a few minutes, that's not too much more difficult than solving for A. And then finally, if you're going to score between 90 and 99 on the test, they might ask you to solve for R, and we'll see 1 or 2 of those examples in this video as well. So as long as you can solve for A, you should be fine on test day. If you're going to score very high on this test, you may want to be prepared to solve for P or R as well. All right, so all that being said, the only real way to understand this formula fully is to work on some problems involving compound interest. So that said, let's go ahead and look at our first problem. All right, this first problem says, use the compound interest formula to answer the following questions. In the formula, A is the amount of money in the savings account, P is the principal, R is the interest rate, T is the time that the money is in the account, and N is the number of times the money is compounded per year. All right, so part A here says, what will be the amount in the account if $800 is invested at 10% and it is compounded annually for 2 years? So when you have a problem involving compound interest, the very first thing you want to do is simply copy that formula down onto your scratch paper. So that's what I'm going to do here. We have A equals P times 1 plus r over n raised to the n times t power. Once you copy down the formula on your scratch paper, you want to go back through the problem, reread it, and identify what information you're given. So to start, we can see the problem says, what will be the amount in the account? If you recall, that was A. So we know in this case, we're going to be solving for A. If $800 is invested, remember your principal is the amount that you invest. So P in this case is 800 at 10%. Well, if you recall, we always express our interest rate in terms of a percent. More specifically, we write it as a decimal, and the decimal form of 10% is 0.1. So we know R in this case is 10%, which we're going to express as 0.1, and it is compounded annually. If you recall, there was some compound vocabulary that I mentioned, and that referred to N. Annually means one time per year, so N is going to be 1 in this case. And then finally, we have time. We know time is in terms of years, so T in this case is going to be 2. Now that we've identified everything, let's go ahead and start plugging things in. We have A equals, principal was 800, so we'll put 800 in place of P, times 1 plus R is going to be in decimal form, and that's 0.1 over N, which is how many times we compound the money. And in this case, it's going to be compounded once per year, so that's 1 there. Raised to the N, again, N is 1, and T is time, and we identified that as 2. All right, so let's keep working this out, and I'm going to have to move down a little bit here. A equals 800 times 1 plus, and this math right here, believe it or not, is pretty easy to do. Anything divided by 1 is itself, so 0.1 divided by 1 is just 0.1. And let me work some examples of that off to the side in case this is your first time finding one of my YouTube videos. 5 divided by 1 would be 5. 100 divided by 1 would be 100. Again, anything divided by 1 is itself. Likewise, anything times 1 is itself. So 1 times 2 is just 2. All right, so let's keep working this one out. We have 800. Now, here we have 1 plus 0.1. You should be able to do that mentally and say that that is 1.1. Okay, but that said, whenever I work out decimals in my videos and I don't do it off to the side, people complain that I didn't show them that step. So I'll go ahead and do this for you. Again, we have 1 plus 0.1. So that's 1 plus 0.1. As you can see, we're adding a whole number and a decimal. So to make sure that this is a little bit clearer, I'm going to add a decimal to 1, and I'm going to add a 0 placeholder. And likewise, I'm going to add a 0 placeholder in front of 0.1. All right, now we can quickly add these. 0 plus 1 is 1. Drop down your decimal in place. 1 plus 0 is 1. So that's how I got that 1.1 there. So let's keep working this out. We have 800 times 1.1 squared. Well, if you recall your order of operations, which you can remember using the acronym PEMDAS, you always do exponents. Again, E is exponents before you do multiplication. So here's an example of that. We have 800 times 1.1 squared. We're going to have to work out this square, our exponent, before we do this multiplication. Okay, so that's what I'm going to do next. And that said, let me go ahead and get rid of some of this. All right, so we have 1.1 squared. Well, that's the same as 1.1 times 1.1. And to show you all the steps involved in that, I'm going to do it like this, 1.1 times 1.1. As you can see, we're clearly multiplying 2 decimals by each other. And the trick to this is to get rid of the decimals completely. In other words, you want to shift the decimal to the right however many times it's necessary to get rid of the decimal. So in 1.1, I'm going to shift the decimal one time to the right. And likewise, in this 1.1, I'm going to shift this decimal one time to the right. So this becomes 11 times 11, albeit with two decimals to move back into the left. So I move those decimal places two times to the right here. I'm going to move it back two times to the left when I get done doing this math. So now we have 1 times 1, which is 1. 1 times 1, which is 1. Before we start multiplication with this one, we have to bring in a 0 placeholder. 1 times 1 is 1. 1 times 1 is 1. Let's add these together now. 1 plus 0 is 1. 1 plus 1 is 2. 1 plus nothing is 1. Bring our two decimals back in. 1, 2. So this becomes 800 times 1.21. And that's going to be the final step that we have to perform to solve this one. And let's go ahead and do that down here. We have 800 times 1.21. Again, as I just did, we want to clear the decimal in 1.21 such that this math becomes a little bit easier because we won't be multiplying a whole number by a decimal. So shift this decimal 2 times, and this will become 800 times 121, albeit with two decimals to shift back into the left at the end when you're done. And as it happens, this math's actually really easy to do. We have 0 times 1, which is 0, 0 times 1, which is 0, 1 times 8, which is 8. Before we start multiplication with this 2, we have to add a 0 placeholder. Now we have 2 times 0, which is 0, 2 times 0, which is 0, and 2 times 2, which is 16. Before we start multiplication with this 1, we have to add 2 0 placeholders. And now we can proceed. 1 times 0 is 0, 1 times 0 is 0, and 1 times 8 is 8. Let's add this all up now. 0 plus 0 plus 0 is 0. 0 plus 0 plus 0 is 0. 8 plus 0 plus 0 is 8. 6 plus 0 is 6, and 8 plus 1 is 9. Shift our two decimals back in, 1, 2. So we can see that A in this case is 968. And this tells you that if you invested $800 with an interest rate of 10%, and that amount of money was compounded annually for a length of time of 2 years, you would have a total of $968 in that account at the end of those 2 years. And as you saw, this math is pretty tedious. There's a reason this question appears on the ASVAB. Again, it tests your ability to square numbers, and it tests your ability to work with decimals. And so, that's why these questions show up frequently. All right, part B says, what amount should a person place in an account if she wishes to have $1,210 in 1 year if the money is compounded semi-annually at an interest rate of 20%? All right, so again, not surprisingly, I'm going to start this problem by copying down the formula that's given, notably A equals P times 1 plus R over N to the NT power. Then I'm going to reread the problem and identify what's given and what I'm trying to solve for. So what amount should a person place in the account? So they want to know how much they should invest. So this amount that they should place in the account is going to be our P. That's what we're going to be solving for in this case. If she wishes to have $1,210 after 1 year. Well, if you recall, A referred to the amount of money in the account after your investment has run its course. So this 1210 is going to be our A. Again, we know time's always given in years, so this 1 year is going to be our T. And what's more, we're told the money is compounded semi-annually. Again, whenever you see the word compounded, you know that's going to be your N. Semi-annually means twice per year, so N is going to be 2 in this case. And then finally, we're told our interest rate, our R, is 20%. we're always going to express that in decimal form, so r is going to be 0.2. So with everything identified, let's go ahead and start plugging things in. Again, we know how much money this person wants in the account after 1 year. So we know A is going to be 1210. We want to know how much they should invest. So we're solving for P in this case. We have 1 plus, what was R? R was our interest rate in decimal form, which was 0.2. N was how often the money's compounded, and we found that to be 2. So this is 2. Again, N was 2. And time was 1 year in this case, so this is going to be 2 times 1. All right, let's start simplifying this. We have 1210 equals P times 1 plus, and let's work this out. This isn't as difficult to do as you think. This says 0.2 divided by 2. So let's work that out the old-fashioned way here. 0.2 divided by 2. If you watch my video on long division, you'll notice that I worked out a lot of problems involving decimals, because decimals appear on the ASVAB sometimes. And in that video, I stressed that as long as the decimal is inside this division bracket, you don't have to make any adjustments whatsoever to perform the long division. All you have to do is bring up the decimal where it stands, and then once you account for that decimal in your answer, now you can disregard it down here. So this becomes, what is 2 divided by 2? Well, 2 goes into 2 one time. 2 times 1 is 2. 2 minus 2 is 0. So 0.2 divided by 2 is 0.1. And of course, this is 2 times 1, which is just 2. All right, let's keep working this one out. We have 1210 equals P. And let me go ahead and work this one out again. You should be able to do it mentally. 1 plus 0.1 is going to be 1.1. With that said, I'll go ahead and work it off to the side for you. We have 1 plus 0.1. We're adding a whole number and a decimal. So I want to express this whole number as a decimal as well. I'm going to place a decimal right there and a 0 placeholder. And if it's helpful, you can put a 0 placeholder there. 0 plus 1 is 1. Drop down your decimal in place. 1 plus 0 is 1. Okay, so that's how I got that 1.1. And as we can see, this says 1210 equals P times 1.1 squared. Well, we're going to have to work that off to the side. So let's go ahead and do that over here. Again, 1.1 squared is the same as 1.1 times 1.1. And I'm going to work that out vertically. Okay, we have 1.1 times 1.1. What you want to do is clear these decimals by shifting them to the right accordingly. So I'm going to shift this decimal 1 time to the right and this decimal 1 time to the right. So this becomes 11 times 11, albeit with 1 plus 1 are 2 decimals to shift back into the left at the end. 1 times 1 is 1. 1 times 1 is 1. Before we start multiplication here, we have to add a 0 placeholder. 1 times 1 is 1, and 1 times 1 is 1. Let's add these together. 0 plus 1 is 1. 1 plus 1 is 2, and 1 plus nothing is 1. Bring our 2 decimals back in. 1, 2. All right, so this becomes P times 1.21 equals 1200. And again, we're solving for P in this case. So this is P times 1.21. To solve for P, we're going to perform the opposite operation there. Notably, we're going to divide both sides by 1.21. This will cross out here. And just to make this simple, I'm going to rewrite it like this. P equals 1210 divided by 1.21. All right, so some of you could probably work out 1210 divided by 1.21 in your head. But that said, if it's test A, you're probably going to be a little bit nervous, which is fine. In that case, I'd recommend that you work this one off to the side. More specifically, you want to read this as 1210 divided by 1.21. So this becomes 1210 divided by 1.21. And in my video on long division, I make a special emphasis on how to deal with decimals. And what I say in regard to decimals being outside the division bracket is this. If the decimal's outside the division bracket, you have to clear it such that that number with a decimal becomes a whole number. So to make 1.21 a whole number, we're going to take its decimal and shift it 2 times to the right, and that's going to become 121. All right. But that said, I also pointed out that to keep proportionality, you have to shift the decimal inside the division bracket a corresponding number of times. And in 1210, there's technically a decimal right here. So we move the decimal twice right here. We're going to move it 2 times here. And then we're going to add 2 0 placeholders. And that number becomes this. That becomes 121,000 divided by 121. Well, this math is actually pretty easy to do. 121 goes into 121 one time. And now all we have to do is bring up these zeros. So we're going to bring up this 0, and this 0. So 121 times 1,000 is in fact 121,000 with no remainder. So we can see our principal in this case is $1,000. In other words, if you want to have $1,210 in this account after a year, and the money's compounded semi-annually at an interest rate of 20%, you would have to invest $1,000. Okay, so that's that one. Again, the math is very tedious, so be prepared to work with decimals if you get a problem like this. All right, so we've reached the point in the video where I strongly encourage you to work out these practice problems on your own. As you can see, there's 3 of them. So after I read a question, you should pause the video, attempt to work out the question on your own, and then resume playing the video to check your solution. Let me stress this. The other day I got a comment about the fact that I don't skip any steps and I work out the problem slowly. You have to bear in mind that I'm creating these videos for people who may struggle with this topic or may have never seen this topic before. So whereas I can personally solve these problems very quickly and skip quite a few steps, it goes without saying that I'm making these videos for the people who need to see every single step. So please don't be the person who makes that comment. All right, with that out of the way, let's go ahead and look at this first question here. It says, if you deposit $4,000 into account, paying 10% annual interest, compounded semi-annually, how much money will be in the account after 1 year? So as I suggested when I worked out the first example, the first thing you want to do is copy down the formula. And again, that's A equals P times 1 plus R over N raised to the NT power. Once you do that, you want to go back and identify what's given to you. Again, in this problem, it says if you deposit $4,000 into account. Well, that means we invest $4,000. So that's going to be our principal, paying 10% annual interest. Well, that 10% is going to be your interest rate. And of course, we're going to express that in decimal form as 0.1. It's compounded semi-annually. Again, compound refers to n, and semi-annually refers to twice a year. So n is going to be 2 in this case. How much money will be in the account after 1 year? Well, 1 year is in reference to time, so we can see t is going to be 1 in this case. And we want to know how much money is going to be in the account. That, of course, refers to A. So in this case, we're solving for A. So with all those things identified, let's go ahead and plug them in accordingly and do the arithmetic that's required to solve this one. So we have A equals, our principal was $4,000. 1 plus our interest rate was 10%, which we express in decimal form as 0.1. N was 2 since it was semi-annually or twice per year. Again, N was 2. and our time was 1 year, so t is 1, so this is 2 times 1. Let's go ahead and start simplifying this. We have 4,000 times 1 plus, and let's work this out. Again, this says 0.1 divided by, and let me move down a little bit. It says 0.1 divided by 2. Again, when we're dividing with decimals, the key is this. If the decimal's inside the division bracket, you're good to go. If it's outside the division bracket, you have to make those adjustments I mentioned in example 2 to proceed. In this case, the decimal's inside the division bracket, so the only thing I'm going to do is bring it up right here. And now I'm going to disregard the decimal down here. So in other words, I'm going to treat this like 1, and I'm going to ask myself, how many times does 2 go into 1? It doesn't, so I have to tack on a 0 placeholder. And since 2 didn't go into 1 itself, I have to bring in a 0 right here. Now the question is, how many times does 2 go into 10? Well, of course, that's 5 times. 2 times 5 is 10 with no remainder, since 10 minus 10 is 0. So this 0.1 divided by 2 is 0.05. And of course, this is 2 times 1, so we know this is just going to be 2. All right, so let's keep working this one out. We have A equals 4,000 times 1 plus 0.05. You should be able to do that mentally. That's going to be 1.05. But that said, I'll work it off to the side. We have 1 plus 0.05. That is to say we're adding a whole number to a decimal. So what you want to do is add a decimal to 1 as well as 2 0 placeholders. And then right here, you can place a 0 placeholder. 0 plus 5 is 5. 0 plus 0 is 0. Drop down your decimal in place. 1 plus 0 is 1. Okay, so that's how I got that 1.05 right there. All right, let's keep working this out. We have 4,000 times 1.05 squared. Well, I'm going to have to work that off to the side. Again, 1.05 squared is the same thing as 1.05 times 1.05. And I'm going to work that out vertically so as not to make any mistakes doing it. Okay, we have 1.05 times 1.05. And as we've seen in this video already, what we want to do is clear these decimals. In 1.05, I'm going to shift its decimal place 2 times to the right, and likewise, I'm going to do the same thing here. So in total, I move the decimal place 4 times, and this problem's now this, 105 times 105, albeit with 4 decimals to move back into the left at the end when we're done here. So let's go ahead and do that. We have 5 times 5, which is 25, so we're going to drop down a 5 and carry a 2. 5 times 0 is 0, plus 2 is 2. 1 times 5 is 5. Before we start multiplication with the 0, we have to bring in a 0 placeholder. 0 times 5 is 0. 0 times 0 is 0. 1 times 0 is 0. Before we start multiplication with this 1, we have to bring in 2 0 placeholders. 1 times 5 is 5. 1 times 0 is 0. And 1 times 1 is 1. Let's add these together now. We have 5 plus 0, which is just going to be 5. 2 plus 0, which is going to be 2. 5 plus 5 is 10, so we're going to drop down a 0 and carry a 1. 1 plus 0 is 1, and 1 plus nothing is 1. Bring in our 4 decimals, 1, 2, 3, 4. So we can see that this becomes 1.1025. And now all we have to do is work out this math here. And that's going to be pretty tedious to do, so I'm going to try to find a good amount of room to do it. So we have 4,000 times 1.1025. Again, we're multiplying a whole number by a decimal. So what you want to do here is shift this decimal and 1.1025 to the right, however many times it takes to clear the decimal completely. So we're going to shift it 1, 2, 3, 4 times to the right. When you multiply numbers, the bigger number comes on top. So this is going to be 11025 times 4,000, albeit with those 4 decimals to shift back into the left at the end when we're done. And this is going to go quicker than you think. Again, we're multiplying by a bunch of zeros here, so that's going to be pretty easy to do. So let's get started doing that. We have 5 times 0, which is 0, 2 times 0, which is 0, 0 times 0, which is 0, 1 times 0, which is 0, and 1 times 0, which is 0. Before we start multiplication with this 0, we have to add in a 0 placeholder. 5 times 0 is 0, 2 times 0 is 0, 0 times 0 is 0, 1 times 0 is 0, and 1 times 0 is 0. Before we start multiplication with this 0, we now have to add 2 0 placeholders. 0 times 0 is 0, 2 times 0 is 0, 0 times 0 is 0, 1 times 0 is 0, and then 1 times 0 is 0. Now we're on to the 4, and we're going to have to add 3 0 placeholders. So that's going to be 1, 2, 3, and now we can begin. 4 times 5 is 20, so we're going to drop down a 0 and carry a 2. 4 times 2 is 8, 9, 10, so we're going to drop down a 0 and carry a 1. 4 times 0 is 0, but we have that 1 there, so that's just going to be 1. 1 times 4 is 4, and 1 times 4 is 4. Let's add these together now. We have 0 plus 0 plus 0, which is 0. Then we have 0 plus 0 plus 0 plus 0, which is 0. 0 plus 0 plus 0 plus 0 is 0. 0 plus 0 plus 0 plus 0 is 0. 0 plus 0 plus 0 plus 0 is 0. 0 plus 0 plus 1 is 1. 0 plus 4 is 4, and 4 plus nothing is 4. Bring in our 4 decimals, 1, 2, 3, 4. So we can see our answer in this case is going to be 4,410. Which means that if we invest $4,000, we get a 10% interest rate, and we invest our money for 1 year, and it's compounded semi-annually, we'll have $4,410 in our account after after that year. Okay, so that's that one. You will experience this difficulty when you get this problem on the ASVAB. So you have to be prepared to know how to multiply decimals in this case. Okay, so that's that one. All right, so number 2 here says, how much money would you need to deposit today at 20% annual interest, compounded annually, to have $12,000 in the account after 1 year? So before we identify what's given to us and what we're solving for, let's start by writing down the equation again. That's A equals P 1 plus R over N to the N times T power. All right, now that we've done that, let's go ahead and reread the problem, and let's identify what's given and what we're solving for. How much money would you need to deposit? That is, how much money would you need to invest? Again, principal is always the amount you invest. At 20% annual interest, well, that's your interest rate. Again, R is always going to be your percent, and what's more, we're always going to express that in decimal form. 20% in decimal form is 0.2. Compounded annually. Again, compounded always goes with N, and annually means 1 time per year, so N is 1 in this case, to have $12,000 in the account after 1 year. Remember, the money in the account after your investment runs its course is A, and in the account after 1 year, of course, that's our T, so we know T is 1. So with all that identified, let's start plugging things in. Again, in this case, we know what A is. It's 12,000. We're trying to solve for P, so we'll leave that as is. 1 plus, what's R in this case? It's 20%, which we're going to express in decimal form as 0.2. N in this case is 1. Again, N was 1, and we know the time was 1. All right, so Let's start simplifying this. Again, we have 12,000 equals P. Let's take care of this division here. 1 plus zero point 0.2 divided by 1. Again, if the decimal is inside the division bracket, all you have to do is bring that decimal up here, and now we can disregard this decimal down here, and the question becomes, how many times does 1 go into 2? Well, 1 goes into 2 2 times. Given that 1 times 2 is 2, 2 minus 2 is no remainder. So this is 1 plus zero point 0.2, and 1 times 1 is just 1. Right? Let's keep working this out. We have 12,000 equals P, and let's work out this decimal right here. This says 1 plus zero point 0.2. Many of you could do that in your head, but that said, I'll work it off to the side for you. Again, we're adding a whole number and a decimal. So I'm going to add a decimal here and a 0 placeholder. And if it's helpful, we can add a 0 placeholder here. 0 plus 2 is 2. Drop down your decimal in place. 1 plus nothing is 1. So 1 plus 0.2 is 1.2. And we can see that that is raised to the first power. Anything raised to the first power is just that number. So 5 raised to the first power is just 5. 100 raised to the first power is just 100. So this simply becomes 12,000 equals P times 1.2. Again, anything raised to the first power is just itself. So 1.2 raised to the first power is just 1.2. And it should be obvious that we're solving for P in this case. So we're going to divide both sides by 1.2. This crosses out here, leaving you with just P over here. And as we can see, P is 12,000 divided by 1.2. If it's test day, you might be a little bit nervous. So instead of trying to do this one mentally, which some of you can do, I know, you can go ahead and do this as long division. Notably, we would read this as 12,000 divided by 1.2. And again, we're presented with a case of long division involving a decimal. In this case, the decimal is outside the division bracket. So as I mentioned, when the decimal is outside the division bracket, you want to shift it 1 time or however many times you need to the right to clear that decimal. So if I shift the decimal in 1.2 1 time to the right, it becomes 12. That said, to keep proportionality, I'm going to have to add a decimal here and shift it a corresponding number of times. So I'm going to have to shift it 1 time and add a 0 placeholder. So this becomes this. This becomes, what is that? 120,000 divided by 12. This is actually pretty easy to do. 12 goes into 12 1 time, and again, just bring up those zeros accordingly. In other words, 12 times 10,000 would be 120,000 with no remainder. So in this case, P is going to be 10,000, and in math, it's customary to write the variable for which you solved on the left. This is P equals 10,000. In other words, if you want to have 12,000 in your account after 1 year and you're given an interest rate of 20% that's compounded annually, you would have to invest $10,000 into that account. All right, so that's that one. All right, so number 3 here says Matt is planning to buy a car in 1 year. He wants to invest $5,000 now and hopes to have $6,000 to spend on the car when he buys it. What kind of interest rate would he need if his investment is compounded yearly? So not surprisingly, I'm going to start this problem by copying down the formula. A equals P 1 plus R over N raised to the N times T power. Then I'm going to reread the problem and identify what's given. So in this problem, it's not obvious as to what T may be, but that said, it's said he's planning to buy the car in 1 year. So in this case, we know our time is going to be 1 year, and he wants to invest $5,000. Again, the amount you invest is always P, principal, and he hopes to have $6,000 in the account to spend. Again, the amount in the account after your investment runs its course is always going to be A. When he buys it, what kind of interest rate would he need? So in this case, we're being asked to solve for R. We don't know what R is. And finally, we're told his investment is compounded yearly. Yearly is the same thing as annually, so that means one time per year. So in this case, we know N is 1. All right, so with all those things identified, let's go ahead and work this problem out. We know what A is. He wants A to be $6,000. We know he's investing $5,000 in the account. This is 1 plus. We don't know what R is. We're trying to figure out what R is, so we'll leave that as just R. N we identified as 1, and N is 1. T we identified as 1, so this is 1 times 1. All right, so let's keep working these things out. We have 6,000 equals 5,000. And let's go ahead and simplify this over here. This becomes 1 plus R divided by 1. Anything divided by 1 is itself. So R divided by 1 is just R. And then 1 times 1 is 1. Anything raised to the first power, likewise, is just itself. So 5 raised to the first power is just 5. Therefore, 1 plus R raised to the first power is just 1 plus R. Okay, so let's simplify that now. We have 6,000 equals 5,000. Again, 1 plus R to the first power is just 1 plus R. All right, so what we want to do now is we want to solve for R. So my next step is to divide both sides by 5,000. This will cross out here, leaving you with 1 plus R over there. And then as far as this 6,000 over 5,000 goes, we can now cross out these corresponding zeros to make this 6 over 5. And now we're just solving for R. So we want to move this 1 over here. So we're going to subtract both sides by 1. This crosses out, leaving you with this. R equals 5 over, not 5 over 6, 6 over 5 minus 1. Okay? And now we have to be good at subtraction involving fractions. And so what I want to do is express this 1 as a fraction. Again, this will become 6 over 5 minus, well, how can I write 1 as a fraction such that it has a denominator of 5? Well, I know 5 divided by 5 is 1. And since these two now have the same denominators, I can go ahead and do this subtraction pretty quickly. Again, when fractions have the same denominators, you just subtract the numerator. So this becomes 6 minus 5, which is 1. Again, and then you don't touch the denominator, equals R. So we can see R equals 1 over 5. Well, as I've said throughout this video multiple times, interest rate, or R, is always expressed as a decimal. Well, in this case, how can we convert 1 over 5 to a decimal form? Well, we can do this long division very quickly. 1 divided by 5. We're asking ourselves to start, how many times does 5 go into 1? It doesn't, so I have to add a decimal there and a 0 placeholder. Then I'm going to bring up my decimal there, and I'm going to say 5 didn't go into 1, so I need to put a 0 there. How many times does 5 go into 10? It's 2 times. 5 times 2 is 10. 10 minus 10 is 0. So R is 0.2, and we should know that 0.2 is the same as 20%. So if Matt wanted to buy this car, and he wanted to have $6,000 after a year of investing $5,000, he would need to have an account that had an interest rate of 20%. All right, so that is it for this video. I hope you found it helpful. Again, since you're not permitted to use a calculator on the ASVAB, These questions aren't going to get especially difficult. That said, as you saw, you have to be very good with decimals and fractions to work your way through these problems. So if you have a chink in your armor anywhere, a question like this is going to expose it pretty easily. As always, you're more than welcome to leave feedback in the comment section below. Let me stress this. Unlike a lot of people who are trying to get you to sign up for their boot camps, I post videos on YouTube such that I show you everything you need to know about a particular topic uh, in that video. So again, if you watch this video and you understood everything in this video, you probably don't need any additional practice. So finally, I'll say if you like the content I'm creating, please consider subscribing to my channel. But on that note, I'm going to go ahead and catch you loose. Konnichiwa.